overlapping that. If you cannot see or anything to ask, please ask here. Okay, so we got so we got 5,000 milligram per liter benzene, 10,000 milligram per liter toluene. And what else? The air volumetric flow rate is 100,000 liter per day. Okay, right. So these are the information that you for the inlet. And what are the information for the outlet? It says that the benzene concentration in the effluent water is 750. So effluent water is here, down here. Okay, effluent water is down here. 750 milligram per liter of benzene. And the removal efficiency of toluene is 70% of removal of benzene. All right, so these are the information that you need to know, that Jimmy told you. Okay. First thing first, what you need to do is to simply convert convert this 5,000 milligram per liter. Try to find how much is the total mass that goes into the system. Okay. In one day, 50,000 liter per day of water come in. Okay, and for each liter of that water, there is 5,000 milligram of benzene. So in a day, how much benzene goes in? Okay. Okay, so there's 5,000 milligram per liter, okay, of benzene, and in total in one day there is 50,000 liter goes in. So at the end, how much is benzene in one day? So just multiply, and you will get the mass of benzene per day. Okay, and you can forget about the per day later on. Okay, but when you calculate this, like how I did this, you will get in milligram. So if the number is too large, okay, if you get million, you can divide with you can divide to 10 to the power of 6, I think, to get to kg. Okay, so you can convert that into kg. Okay, convert that into kg, you will get a more easier number to handle. Okay, do that similarly for toluene. Okay, do that similarly. 10,000 milligram per liter multiply with 50,000 liter per day, you will get mass of toluene. Similarly, you get mass of toluene per day. Remember, you can calculate either in milligram or kilogram. Okay. If you are confused how to change milligram to kilogram, let's say you got let's say you got 2.5 million, for example, milligram. Okay. So how to convert that to kg? Okay, 1000 milligram to 1 gram. Okay. 1000 gram, 1 kilogram. Okay, to those who perhaps don't know how to convert milligram to kilogram, so have a look at that screen on the right hand side. Okay, this is pretty much you do. Divide with, actually divide with 10 to the power of 6, but I put it in this way so that you get the idea on how. Okay. Okay, you cancel out those gram and milligram. What we left is just milligram. Okay, it will be a smaller number, easy to handle. Now, the first okay. Now, the first thing is they already give you 750 at the bottom here. Okay, this one here. So actually, this is already solved half of the thing. Okay. Now, if this is 750, pretty much the removal efficiency of benzene right, whenever you need to calculate on efficiency, okay, remember this particular formula. So initial minus final over initial. So initial here is if you already calculated the mass per day, you can use that if you get the value of that. Otherwise, you can still use the concentration. It's still the same. Okay, I use here the concentration. This 5,000 here I put here is the concentration. It's the same whether you use concentration or the mass that we calculated. Doesn't matter. So 5,000 minus 750 times 100. Okay. So this is how you calculate efficiency, removal efficiency of benzene. Say the initial is the initial from wastewater, final is the one at the effluent, which is 750. Okay, I use here value of concentration. As I mentioned, doesn't matter. So what you will get here?
%85.
Okay, right. 85%. Okay, so now you got the removal efficiency of benzene, but how to know what is the concentration or amount of toluene down here? Okay, in milligram per liter, or if you already convert to kilogram, doesn't matter, you can use kilogram. So what is the concentration here? Okay, in the question is already tell you that the removal efficiency of toluene is 70% of benzene. Okay, that is pretty much straightforward. It's just 0.7. Okay, 0.7 means 70%. Multiply with 85%, and you will get the actual removal efficiency of toluene. I will just put it RE here. Okay, it means removal efficiency of toluene. Okay, sorry, it's overlap with that calculation on the right hand side. Okay, that 70% written in that question is not the removal efficiency of toluene. Okay, it's just say that the removal efficiency of toluene is 70% of removal of benzene. Since the removal of benzene is 85%, so 70% out of 85%, you need to calculate, and you will get the actual removal efficiency of toluene, which is how much? How many? Is it 50 something?
59.5%.
59.5? Okay. So this will be the actual removal efficiency of toluene. Now, using back this formula here, initial minus final over initial, okay, using that, you can calculate how much toluene is actually down here. You can calculate that. How? Okay, the removal efficiency is 59.5. I put that in over 100. That means 0.595. Okay. I put that, I mean, that 59.5%. Okay, this is percent. Sorry. Okay, this is 59.5%. So I put it over 100. So it's 0.595 equals to initial for toluene is 10,000. Okay, minus X over 10,000, and this is of course U times 100%. Okay, there you go. So this is how you calculate what is the amount concentration of toluene at the effluent wastewater. Okay, you use back this formula here, initial minus final over initial times 100%. Okay. This X here, if you see, this is multiplier. It's not nanti jangan ada kuasa 2 pula kat situ. So you try to find the X here. Okay, what 10,000 minus X, because X represent the final concentration over 10,000 times 100%. Solve for X and you will get what is the amount of toluene at the bottom. Okay, anyone who calculated, you can tell me what's the amount.
I got 4,050 milligram per liter.
Yeah. Again, 4,000.
4050. 4,050.
4050. Okay. So this, remember I use concentration. Okay, so remember I use concentration here. This is the concentration. If how, since the question asks you to calculate the mass, okay, have a look at the question. It says calculate the mass. I use concentration here because it give in the question it give us concentration. Okay, that is not the mass, that is concentration. So how do you change your answer into the mass? This is it right here. I already showed you earlier. Okay. 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 This one in the green box on the right hand corner. Okay. Is how you convert concentration into mass. Right. So the question asks calculate mass. So please convert concentration into mass. Right. So what else? So we got toluene at the bottom. Now what is the, okay, remember where the rest goes. Okay, 5,000 milligram per liter of benzene goes in, only 750 at the bottom. So where the rest of benzene and toluene goes? It's here, right? Okay, I put it in the color. There. So how much benzene up here and how much toluene up there? Okay. Now, if you calculate that in mass, if you convert in mass, so what simple subtraction? Okay, but put your answer wrong. Explain why. Right. Okay. Before that, I will just show you how to get the amount of B benzene and T up here. Okay. If you already convert in mass, so if you already got the mass of each benzene and toluene, you already convert that. So it's pretty much straightforward. You just minus the B that, let's say, B in from the wastewater. Okay, let's say here for B, can I put that as let's say X, let's say X. Okay, let's say it's X for mass of benzene here in kilogram, and the one here at the bottom, the one with the concentration 750, you convert into mass, which is you multiply with the volume 50,000, you get Y. Okay, I hope this doesn't confuse you because I calculate this. So basically, to calculate B in the air here is just X minus Y, that's all. Okay. I hope you can follow here. This X is you convert the benzene concentration into kilogram, and this Y here is you convert the concentration of benzene at the effluent, you convert that into mass as well. Now, if you have both in mass, as I mentioned, forget about the per day. Okay, it's mentioned per day, but don't worry about that. If you minus those two, you will get the mass of benzene up here. Okay, you will get that immediately. So it's just a simple subtraction and you get the mass of benzene. Similarly, if you do that for toluene, again in mass, in kilogram, or if you fancy big number, you want to leave it in milligram. So whatever unit you use is just minus. But this can only happen if you have your answer in mass. Okay. In concentration, if you minus 5,000 milligram per liter benzene here to 750, okay, let's say here, okay, let's say this is in concentration. Yeah. Okay, have a look on the left hand side. Let's say you say, okay, the amount of benzene, okay, since mass balance, whatever goes in must goes out, so the amount of benzene here must be 5,000 minus 750. Surely it must be that. Okay. And you will 250. Okay, let's say you calculate concentration per liter in minus 750. So whatever remaining the amount here. Now, right? Calculation of of that you calculate percent flow rate. Okay, have a look at the volumetric flow rate of air and have a look at the volumetric flow rate of wastewater. The volumetric flow rate of air is double the volumetric flow rate of wastewater. The wastewater goes in at 50,000 liter per day, where the air comes in at 100,000 liter per day. It's double. Okay, the air is double the amount than the water. Okay, in terms of volumetric flow rate. Okay, so that's why when you calculate 5,000 minus 750, and you mentioned that as the amount of benzene in the air effluent. Okay, we call up the air effluent. This is air effluent. Okay, that is the air effluent. So if you do that, you say that 4250 milligram per liter of benzene in air effluent, that will be wrong. Okay, because the volume of air is 100,000 liter per day. That means you need to do some conversion actually. You need to adjust that now the volumetric flow rate is 100,000. So benzene will be more diluted. So the amount of concentration is actually lower. Okay, we don't have to calculate that because the question didn't ask the concentration. The question just asked the mass. So that's why I show you how to convert the mass earlier, so that you don't have to bother making mistake putting your answer in concentration. Right. So that's how you get the answer for quiz 1. I think I answer all of that. Yeah. Okay. Any question? Sorry that I have to annotate in this way, but I hope you can follow. Is it okay, this calculation? So at the end of the day, you calculate on your own what is the answer here, x minus y. X refers to the mass of benzene per kilogram. How to calculate that here? 5,000 milligram per liter, just multiply with 50,000 liter per day, that's all. And convert that into kg. If you fancy milligram, just remains in milligram, but that's a big number. And minus whatever mass of benzene at the bottom, then you get mass of benzene at the end. Just a simple subtraction. Tolak je. Do it similar for toluene. Okay. For this particular quiz, I think student make mistake your previous senior Okay, always make me take at this particular point. One is this removal efficiency. Okay, hang on, put it in purple here. This part, this bit, quite a number having trouble. What does efficiency means? Okay, having trouble of this meaning, and some of them using 70% as the removal of toluene instead of calculating in this way. And another one is conversion, unit conversion. Okay, quite a number having trouble to convert unit, right? Even to change milligram to kg, also having trouble. What I noticed last time is instead of divide, for example, here 2.5 million divide with 1,000 times 1,000, they multiply 1,000, multiply 1,000, and they get around some few billion. Okay, so those two things you need to be careful on. Okay, unit conversion and also what is the meaning of efficiency. All right, I think that's all that I should cover for today. Any question? Are you okay with the calculation?
Okay.
All right, if that's the case, right, so this will be the last session with you guys. Obviously, during the final exam, it will be like test 2. I will put in Google. We will do Zoom for monitoring, and then you need to put your answer in Google form. Okay. Otherwise, okay, all the best, and